So now let's look at some body cavities. And body cavities, as the name implies, are spaces or holes within the body. And we can divide them into posterior or dorsal body cavities and ventral, anterior or ventral body cavities. And we're going to look first at the dorsal body cavities. And we have two cavities that we're going to consider. The cranial cavity, which is contained within the skull. The part of the skull that holds your brain is the cranial cavity. So this is the cranial cavity. And then we have the vertebral canal, also known as the spinal cavity. And it is continuous with the cranial cavity. And so here, what we've done on this model is we have taken the posterior part of the vertebral column and cut off the posterior part of each vertebra so that you can see inside. And you can see the spinal cord. And we have one vertebra here that we can pull out, and we can see within it the spinal cord. So the spinal cavity or vertebral canal contains the spinal cord. And if we take the spinal cord out, you can see that each vertebra has a little hole called the vertebral foramen. And this is the hole through which the spinal cord passes, and the vertebral canal continues the length of the vertebral column. And this contains the spinal cord. That's this yellow thing right here. So you can see it contained within the vertebrae here. And so those are our two posterior or dorsal body cavities. We have a few other body cavities that we can consider that are sort of minor or smaller body cavities, one of which is the body cavity in which we find the eye, and that's called the orbital cavity because it's contained within the orbit of the skull. So this is the orbital cavity. You can also see it here on the skeleton, the orbital cavity. And you'll find the eyes within the orbital cavity. Then we have the oral cavity, which contains the mouth, or I should say is within the mouth. We have the nasal cavity. We have the middle ear cavity, which you can't see here. It's sort of interior, but it's where you have the tympanic cavity, which is part of the auditory system, and this is where you have what are called auditory ossicles, and these are three bones that are very important for the transduction of sound. And your middle ear cavity would be contained within the temporal bone of the skull. Now we can look at our ventral body cavities. So I'm going to go over to this model for that. And really, you could consider the orbital cavity, the nasal, and the oral cavity on the ventral aspect because they're on the anterior part of the body, but they're not part of the major body cavities. When we consider the ventral body cavities proper, we're really talking about the thoracic cavity and the abdominopelvic cavity. So here we have our model, and we can consider first the thoracic cavity, and that's everything contained within the chest. So the thoracic cavity is bounded by the rib cage. So the rib cage contains the thoracic cavity, and the thoracic cavity is bounded on the inferior portion by a sheet of muscle called the diaphragm, and that would be this sheet right here. And this is a muscle important for breathing. So the diaphragm denotes the lowermost part of the thoracic cavity, or you should say the floor of the thoracic cavity, and all of these organs are within the thoracic cavity. We then have the abdominopelvic cavity, which is everything from below the diaphragm into the floor of the pelvis. So we can further divide the abdominopelvic cavity into the abdominal cavity and the pelvic cavity. And before we get into the abdominopelvic cavity, I'm going to focus a little bit more on the thoracic cavity. So the thoracic cavity contains within it several other cavities. And these cavities are associated with certain organs. So we have our lungs and our heart. Here's our heart. Here we have some lungs. And these organs are going to be surrounded by a very specialized membrane. And the membrane that we're talking about is called a serous membrane. So to demonstrate a serous membrane, I'm going to use this freezer bag because it is a two-sided, or I should say double-sided membrane, if we treat it like this, we can consider this freezer bag our membrane that wraps around the organ. And it's called a serous membrane because it has, between the two layers, it has a very thin film of fluid called serous fluid. And the serous fluid is important because it allows the two sides of this membrane to slide over one another. And that allows there to be some freedom of movement. So when we consider that an organ is covered with a serous membrane, we have the inner layer of the serous membrane that would be flush against the organ. And that is called the visceral layer, because you can think of viscera being the organ and the visceral layer being flush up against the organ. Then you have the outer layer, which is called the parietal layer. And between the visceral and parietal layer, you have this very, very thin space between, which really isn't a space at all. It's where you find the serous fluid. And this acts as a kind of lubricant to allow the two layers of the membrane to slide over one another very easily. And when you consider that the fact that the heart is contained within a serous membrane called the pericardium, and peri means around, and cardia has to do with the heart. So you've heard of cardio, that has to do with the heart. So the pericardium surrounds the heart. We have a similar serous membrane that surrounds the lung, and it is called the pleural membrane. And again, it's a two-sided membrane that has a visceral layer and a parietal layer, and between the two layers you have this very slick serous fluid which allows the layers to slide over one another. And when you consider the action of the heart beating as a pump, and you consider the action of the lungs inhaling and exhaling, you can see that there's quite a bit of change of shape in these organs. And they have to be able to slide over one another without generating friction. And so this is why the serous membrane is important. And the serous fluid is what allows that to happen. Now, another important thing to understand is that the potential space where we find this fluid is what we call the particular cavity. So what I mean by that is when we have our pericardial membrane here, the pericardial space is the space between the two sides of the pericardial membrane. So the pericardium is the serous membrane that surrounds the heart. The pericardial space is the space between the visceral and parietal layers. So when we say that the heart is surrounded by the pericardial cavity, we mean exactly that. We mean that the heart is actually surrounded by it, not within it. Technically, if the heart were within the pericardial cavity, it would be inside the bag, which it is not. It is surrounded by it. And the same is true with the lungs. So the pleural cavity is a cavity that surrounds the lungs. Now, both of these things, both of these membranes can become inflamed. You could have an accumulation of fluid, or you could have an infection inside the membrane that could then impinge upon the function of the organ, or basically impede it. And this is a situation that when we see it around the heart, it's called pericarditis. When we see it around the lungs, it's called pleurisy. And pleurisy can be quite painful. It's difficult to breathe because it feels like someone's holding your lungs. So keeping the serous membrane intact and functioning correctly. Now, while we're in the thoracic cavity, we should look at this section right here, which is called the mediastinum, which is the central part of the thoracic cavity that contains things like the esophagus. If you could see it, we would have the thymus in here as well. It contains the heart within the pericardium. So I should put my pericardial membrane and the pericardial cavity. But the mediastinum itself is not a cavity. It is just a collection of tissues and organs within the center of the thoracic cavity. On either side of the mediastinum, we have the lungs. And each lung is contained within its own pleural cavity. So I should say each lung is surrounded by its own pleural cavity. So you have your left and right pleural cavities. You have your pericardial cavity, which surrounds the heart. And the heart itself, including the pericardium, is contained within the mediastinum. So these are the things that you find within the thoracic cavity and the subdivisions of the thoracic cavity. Now, we can look at the abdominopelvic cavity. And that is everything from the diaphragm all the way to the pelvic floor. So the abdominal cavity contains most of our digestive organs. It's going to contain our liver, our gallbladder here, our stomach, our pancreas, our kidneys, our small intestine, large intestine, and so forth. Many of these organs are also surrounded by a serous membrane. And this serous membrane sort of interdigitates and wraps around a lot of these organs, and it is called the peritoneum. And so if I put my stomach back in here, we would see the peritoneum basically wrapping around the organs and interdigitating around the organs like this. So these organs, a lot of your digestive organs, are surrounded by the peritoneal cavity. The interesting thing is not all organs are surrounded by the peritoneum. We have some organs that are behind it. These organs are called retroperitoneal because they're not surrounded by it, but they are locked into the back body wall, and the peritoneum touches them, but it does not surround them. In this case, for example, the pancreas and the kidneys are both what we call retroperitoneal, and their anterior surface here will be in contact with the parietal part of the peritoneum, because once again, they are not within the peritoneum, but they are behind it. Organs that are surrounded by the peritoneum are called intraperitoneal organs. Now let's have a little bit more of a look at the divisions between the abdominal cavity and the pelvic cavity. So as we know, the abdominal pelvic cavity is this entire space from here to here. So the abdominal cavity contains most of our digestive organs, and the pelvic cavity contains the reproductive organs, the rectum, the bladder, and so forth. So if we want to look at the pelvic cavity a little bit more closely, we can sort of get our landmarks from this pelvis here. So here we have a pelvis, and you can see the model represent the iliac crest. So this is the ilia. Each one of these is an ilium, which make up some of the bones within the pelvis. This whole thing is the pelvis. Now this part of the pelvis right here is called the pelvic inlet. And from the pelvic inlet to the floor would be our pelvic cavity. So everything pretty much from here to the floor. Once again, that's going to contain most of our reproductive organs, the rectum, and the bladder. A lot of these organs are what we call infraperitoneal because the parietal portion of the peritoneum overlies them, but once again, the peritoneum does not surround them. So we see that the peritoneum spans most of the abdominal cavity and part of the pelvic cavity. So you can find the peritoneum within both. Now let's sort of put everything back together again. So once again, our pelvic cavity is here, and we can start to put our organs back. And we can see here our small intestine framed within the large intestine here. And then we have our stomach, which is going to be anterior to or in front of the pancreas here and the kidneys. We also have our liver and our gallbladder. That's going to be here. Then we're going to have our diaphragm, which is that sheet of muscle that separates the thoracic cavity from the abdominopelvic cavity. And then within the thoracic cavity, we're going to have our mediastinum, which is going to contain the heart surrounded by the pericardium. We're also going to have on either side of the mediastinum, we're going to have our two lungs, each of which is within its own pleural cavity. Sometimes putting these things back together can be quite the task. So I'm going to have to take the diaphragm out for just a moment to get the lung back in there. And then we can put this back. And sometimes these models can be quite the thing to put together and take apart. And now we could put our heart back in. And our other lung. And that concludes our introduction to the body cavities.